Hi, my name is AMANI binti Bandusmadi, matrix number BB215161018, and today I will be presenting my individual assignment on the ethical implication of big data, or BDA for short. In this presentation, I will walk you through what big data analytics is, how it is used in business, specifically Amazon, the ethical challenges it raises, and my personal stance and recommendation, and how to use it responsibly. What is big data analytics? Big data analytics refers to the process of collecting, sorting, and analyzing massive volume of data to uncover trends and patterns that help businesses make better decisions. Is it often described using 5 V's: volume, velocity, variety, veracity, and value. With the rises of technology like head of cloud platforms such as AWS and Google Cloud, and the integration of artificial intelligence and machine learning, big data analytics has become a core business tool across industries like retail, healthcare, finance, and manufacturing. One of the best real-world examples of big data analytics in action is Amazon. Amazon collects data from every customer interaction, browsing history, purchase history, search inquiries, rating, and even location. This data powers Amazon's famous recommendation engine, which is responsible for approximately 35% of its annual revenue. Features like customer who bought this also bought are driven by this data. In 2024, Amazon launched Rufus, a generative AI as a shopping assistant that uses big data to guide customers through product discovery via conversational search. Amazon also used big data analytics for dynamic pricing, adjusting product price in real time based on market demand, competitor pricing, and stock level, all made possible through continuous data analysis. However, big data analytics come with serious ethical challenges. I identify 4 main issues in my report. First, privacy. Data is often collected and analyzed without the user's full knowledge or informed consent, creating a power imbalance between institutions and individuals. Second, algorithmic bias. When AI systems are trained on historically biased data, they can produce discriminatory outcomes, especially in areas like recruitment, lending, and criminal justice. Third, lack of transparency. Deep learning models are often described as black boxes. Even the designer cannot fully explain how decisions are made, making it impossible for those affected to appeal. Fourth, data ownership. Many consumers are unaware that their data is being collected and sold to the third-party organization. These issues have real consequences. Meta, for example, was fined 1.2 billion under the GDPR in 2023 for mishandling user data, the largest fine ever issued under the regulation. To analyze this issue, I applied 2 ethical frameworks. From utilitarian perspective, big data analytics can be justified because it improves healthcare, increase economic efficiency, and help prevent fraud, benefiting the majority. However, utilitarianism alone is insufficient because it can overlook the harm done to minority or marginalized groups. From a deontological perspective, specifically content ethics, businesses have a moral duty to respect individual autonomy, to obtain proper informed consent, be transparent, and allow people control over their own data. This is also the foundation of GDPR. So, the ideal ethical approach combines both utilitarianism to guide societal benefit and deontology to protect individual rights. On a personal level, I believe that ethical big data analytics must be grounded in truthfulness, fairness, responsibility, and respect for privacy. Hiding data policy in lengthy terms and conditions does not count as meaningful consent. Ethical leadership also plays a crucial role. I recommend that organizations appoint a chief data ethics officer, build diverse data teams to reduce embedded bias, and make ethics part of the technology development process from the start. My key recommendation was: first, privacy by design, minimize data collection and apply encryption from the beginning. Second, algorithm audits, conduct regular independent audits with diverse stakeholders to detect and correct discriminatory outcomes. Third, explainability. Ensure individuals can understand and challenge decisions made about them by automated systems. Conclusion: big data analytics is a powerful tool, but its power must be matched with responsibility. Amazon showed us what big data analytics can achieve commercially, but also what ethical risks come with it. The real competitive advantage does not come from exploiting data, as Don et al. 2034 puts it. The competitive edge lies in the responsibility use of data. Thank you.